number 2. Number 2 on page 218. And I know what some of you are saying right now, word problems. Those look like word problems, but those are not word problems. That's the good news. These are not word problems. They're just problems with words, right? There's a difference, because when you have word problems, you gotta let x equal the unknown, you gotta figure out all these things, come up with a big fancy equation and solve the equation and know a lot of previous concepts to be able to solve those things. But this is just a simple ratio problem. Look at number 2. It says, if 8 pounds of dog food costs $6.50, all right, set up a ratio of what? 8 pounds is to, what is it, 650? Then what would that equal? On the other side of the equation, it says, what would you expect to pay for 25 pounds? So if this is pounds per dollar, on the other side, we got to get pounds per dollar, right? So what would it be? 25 pounds. And it says, how much would you expect to pay? That means how much means x. X is the amount that you expect to pay. There's your ratio. And then what do you do to solve for x?
Multiply.
8x equals 650 times 25. And then to get x, what would you do? Take the 650 times 25 and divide by 8. Okay? And what did you get? Round it to the nearest cent. $20.31. Okay? Now, isn't that simple? That's so easy, you probably didn't even need an explanation of that. I got another question for you. How did I know to put the pounds over the dollars? How did I know to put the pounds over the dollars? And the answer is, it doesn't matter. If you put the dollars over the pounds, it would have worked out just as well. If you had pounds, if you had dollars over pounds, that would be like 650. Let me get a different color here so I won't run into that. 650 divided by 8 pounds equals to x dollars divided by 25 pounds. And then when you go to solve the equation, what do you have? 8x equals 650 times 25, exactly the same thing you had there, you see? So you can't lose unless you're not paying attention and get one of them upside down from the other. As long as you're consistent, it's going to work. Just set up a ratio equal to a ratio which is called a proportion. Okay? Another example would be like number 14. Number 14 on page 219. Page 219, number 14. And it says, a gardening chemical is to be applied at 7 teaspoons per 300 square feet. You ever done that? Mix up chemicals and things, or mix up a recipe, or whatever. All right, so if I set up a ratio of 7 teaspoons is to what? 300 square feet. Then what would that equal? The rest of the problem says, how many square feet, where does x go? In the denominator, right? So that would be x square feet. And it says, how many square feet can be treated by 100 teaspoons? So I got 100 teaspoons. And there's the ratio. How do we clear the fractions? 7x equals 300 times 100, and therefore x equals 300. What is that, 30,000? Divided by 7, and round that to the nearest. Well, we're talking about square footage here, aren't we? Nothing accurate about this. It might be appropriate to round it off some. What would you have for an answer? What are the numbers? 4285 point blah blah blah. But hey, actually actually what it is 4,300, right? About 4,300 square feet. I mean, this is not a precise thing. We're just trying to figure out how many square feet of coverage do we have for this particular gardening chemical. Okay, any questions on that? Now go back to page 204. On page 204, sometimes the fractional equations are in the form of addition and subtraction of fractions. And in these cases, we're going to start by finding the least common denominator. So I want to start with number 18. Number 18. Number 18 on page 204. And the equation says x times x plus 1 over 6 minus x over 3